Hi everyone, welcome to STEM Fridays. Today we're going to talk about who is Cortechs Robotics. Then we're going to have the speaker of the day, Miss Toni McFarland, and she's an engineer at John Deere, and she's actually the president of the National Society of Black Engineers chapter in North Carolina. Then we're going to go on to the STEM activity of the week, which is a Rube Goldberg machine. And lastly, we're going to do a short Q&A where you guys can ask questions. So, what is the robot? Stop the video and think about it. So these are some examples of robots from mainstream media, such as R2-D2, WALL-E, Baymax, and BB-8. So maybe some of these came to your mind. But what really is a robot? It's a machine capable of carrying out a complex series of actions automatically, especially one programmable by a computer. And who are we? Who is Cortechs Robotics? So we're a local high school robotics team, and we actually work out of the Cary Town Center Mall. And we have high school students from a bunch of different schools across the Cary, Morrisville, and even Raleigh area. So what we do every year is that we build and program a 120-pound robot in only 6 weeks. And another thing that we love to do is spread STEM in the community, like we're doing right now. This is a video from our competition about a month ago, and it'll show you guys what our team is all about. Robot that we actually built, and a lot of the concepts from the STEM challenges are actually directly applicable to building something like that. So let's talk about a little bit about what do you know? What is programming? How is programming used in the real world? Have you ever programmed before? You can pause the video and think about these for a second. So programming in simple terms is basically what pours life into a robot. So it tells a central electrical component exactly what to do to control motors, different sensors, so that a robot can actually function. And programming is used in the real world in a variety of settings, even on the laptop that you're using to view this video right now. And have you guys ever programmed before? There are several languages such as Python, Java, C++, Fortran, and a lot of the programming language that a lot of junior FLL teams use is LabVIEW. So you might be more familiar with that. So what is engineering? Well, engineering is basically using physical design principles to construct something. And some real world examples of engineering are bridges, buildings, electrical components, your phone, and the engineering to design process. This is really important whenever you build something. So let's talk about it a little bit. So the first thing that you want to do is ask, what are you trying to build? Or what is the problem that you're trying to solve? So in this case, you're trying to build a Rube Goldberg machine. Then you want to do a little bit of research about the nature of the problem. So like, what is a Rube Goldberg machine? What is the best way I can make this? Next, you want to imagine possible solutions. So you want to think about how your machine may look like, how it can get a ball to drop into a cup and stuff like that. And next, you get to plan by selecting a promising solution that you just imagined. And you can do detailed planning by either drawing a sketch of what you're planning out, or you can use something called CAD, or computer-aided design, where you basically draw a really detailed replica of what you're planning to build on a computer. Next, you want to create a prototype. So this might be out of a couple rough materials. It might be paper, it might be wood, just to get an idea of what your final product is going to look like. Next, you're going to test your prototype. So evaluate it. Is it doing what you want it to do? And then you start thinking about, how can I make this better? And finally, you improve your original prototype by redesigning as needed and you keep going through this cycle until you've gotten something that you're proud of and that satisfies the solution. So as we talked about, here's some real world applications of both programming and engineering. The first one is virtual reality, which you guys might use for video games and stuff like that. The next is actually medical devices, such as MRI and CAT scans. And it's also used in artificial intelligence, which is a new and upcoming field where basically you're trying to mimic how a human thinks with a robot. And that can be really useful when making clinical decisions, when trying to sift through a large amount of data and stuff like that. And lastly, it's even used in aerospace. So the shuttle that you see to the left is completely designed through engineering principles, and rocket scientists need to know exactly how this is going to react with the surrounding atmosphere and figure out what the optimal design is to create a successful mission. And next up, we're going to have Miss McFarland talk a little bit about her STEM experience and what you guys can do to get more involved.
Welcome to STEM Fridays. My name is Dr. Tony Arnold McFarland, and in a moment we're going to talk about why I'm wearing this hat and my dad's racing jacket and how it inspired me in STEM. All right, so what I'm going to talk about briefly is my STEM story and what I have enjoyed about studying science, technology, engineering, math, and how I got into it myself. Well, first of all, my name is Dr. Tony Arnold McFarland. I went to North Carolina State University. I'm originally from Spartanburg, South Carolina, but I now reside in Raleigh. And this slide is just a quick timeline, I guess you could say a momentum of my STEM journey. So you can see my early life as a child. Most of my STEM inspiration came from being around the things my dad was involved in. And then some of my most memorable moments include me winning my first science fair in the 6th grade. It was on the solar system. I was very interested in the sky and beyond. Fast forward that high school, I got a chance to meet an astronaut. Fast forward that college, I got a chance to work on fighter engines. And then fast forward that to my professional world, I got a chance to work for, or continue to work for John Deere, a company that feeds the world, and we make equipment for that. And some of my special interests include volunteering and doing STEM activities in the community. And in the future, I'm interested in artificial intelligence and how that can be used to advance our lives. And I also enjoy documenting untold stories. This is a picture of a John Deere retiree who is in his 90s, early 90s. And I got a chance to meet him and hear about his story. He started at John Deere in 1948, and he was the first African American to work in the office. So he was a welder. He later worked in industrial engineering, but it's a wonderful story and very inspiring. So I like hearing about stories that inspire me. So, what things were interesting to me as a child? So, you can use this information to learn something about yourself. Well, for one, I was very interested in understanding how things work. Clocks, TVs, cars, stoves, small appliances and devices. We didn't really have computers like you have them now, so just I had to get the information by reading books, encyclopedias, and we used to have some books called Tell Me Why, and we would go to those books to answer these questions, or I would go to the library. I also enjoy exploring the sky and beyond. I would just enjoy looking up at the sky and wondering what was beyond the clouds. If there was a storm outside, I wanted to like see what the clouds were doing. I'm still like that today. And when it snowed, I wanted to see what the clouds looked like. I had not been on a plane yet, but I wondered what it would be like to be on a plane. Sometimes my dad would just take us to the airport so we could see planes take off. I also had some time where I enjoyed music, I enjoyed writing, and I just enjoyed having an imagination and being creative. So those were the things that were interesting to me as a child. And think about your own life and things that are very interesting to you. And then you'll find your way into your future and how those things will connect you and kind of make a path for you as you decide what you want to do when you grow up. So back to who inspired me. My parents, both of them were teachers. My mother was an English teacher, so that kind of inspired my writing and me wanting to explain things in journalism and talking and things like that. My dad was an automotive mechanics and industrial arts teacher, so he was always working on things, and I was always right there beside him, handing him tools. I'm asking him what he was doing and asking him if I could help. And this is me right here. This is my older sister. This is my younger brother. We were all around them quite a bit and were inspired into STEM. So my sister is a medical doctor and my brother is an engineer at Ford Motor Company. So they also got inspired with that. I got exposure to STEM also through the life around me. This is my grandfather, and this is my mother and her siblings, some of them when they were younger. This picture is probably from like the late 30s or early 40s, somewhere in there, 1940s. My grandfather farmed. That was a primary source of livelihood for a lot of Americans at one time. Agriculture was is a major part of the history of our nation. So I was exposed to crops and harvesting and planting. My grandfather had some cows and chickens and hogs. And again, my dad was into automotive technology. He worked in NASCAR at a very, I would say, tough time in the United States for race relations. So he had a lot of challenges. Just wanted to be a part of a sports that was not accepting of their team. And this is a picture of him. He made like a cabinet, a closet type of furniture, and I was always just kind of watching over his shoulder and learning. And I also like exploring nature, going to science camps, and being a part of ventures that would allow me to explore science. All right, so a little deeper on the stories and the people that inspire me. I got a chance to be around Mr. Wendell Scott. If you saw the movie Cars, this photo of this River Scott, car number 34. The story of River Scott in the Disney films Cars is based off of the life story of Mr. Wendell Scott. And he was kind of the underdog of NASCAR. He had to learn how to recycle he had to learn how to use parts that other people were throwing away. They didn't really have the same funding and budget that the other racers had, like the Petty family. So, or the Pearsons, and there were some other, NASCAR families. But in spite of that, that made them have to be very good problem solvers, and it made them have to be very efficient in what they were doing, because they loved the sport. And these are just some photos of them talking about maybe a problem that was going on at the race. And here's one. My dad told me recently that there was some kind of a NASCAR inspection, and they had to inspect the cars and make sure they were all to compliance. And NASCAR had identified some issue, and they were kind of arguing with them about it. So that's what that picture is from. But anyway, I'm going to let you guys watch a short video on StoryCorps on Windows Sky. So we'll take a moment and let you watch that.
He started racing in 1952, and, it was like Picasso, like a great artist doing his work. And he was in that car, and he was doing his work. But, he couldn't get the support where other drivers that we were competing against had major sponsorship. He did everything that he did out of his own pocket. And as children, we didn't have that leisure time. We couldn't go to the playground. He said to us, "I need you at the garage." I can remember him getting injured, and he'd just take axle grease and put it in the cut and keep working. But he wasn't allowed to race at certain speedways. He had death threats not to come to Atlanta. And Daddy said, "Look, if I leave in the pine box, that's what I got to do, but I'm going to race." I can remember him racing in Jacksonville, and he beat them all. But they wouldn't drop the checkered flag. And then when they did drop the checkered flag, they had my father in third place. One of the main reasons they gave was there was a white beauty queen, and they always kissed the driver. He finally got the money. But, of course, the trophy was gone, the fans were gone, the beauty queens were gone.
Did he ever consider not racing anymore?
Never. That was one of my daddy's saying, when it's too tough for everybody else, it's just right for me. Like I can remember one time when we were racing Atlanta 500, and he was sick. He needed an operation. And I said, "Daddy, we don't have to race today." He whispered to me and said, "Lift my legs up," and put me in the car. He drove 500 miles that day. He always felt like someday he's going to get his big break. But for 20 years, nobody mentioned Wendell Scott. But he didn't let it drive him crazy. I think that's what made him so great. He chose to be a race car driver, and he was going to race until he couldn't race no more.
All right. So after watching that video, you may understand a little bit more about Mr. Scott. I got a chance to grow up around him and hear his story and kind of live it. I did get a chance to go to some of the races. And in spite of the challenges, they were able to leave a legacy. His grandson now has a foundation that is in Danville, Virginia. They offer STEM programs, they offer scholarships, and they offer opportunities to youth at risk. So hopefully one day I'll get to go up there and visit with them. Another person that I mentioned earlier was Dr. Rona McNair. I got a chance to meet him in high school when I was in the 10th grade. He came to our high school in Spartanburg, South Carolina. Dr. Rona McNair was from Lake City, South Carolina, and he was an astronaut. So when I spoke with him, I was not yet sure that I wanted to study engineering. I thought it was too hard for me, And I told him I was interested in music and engineering. I was undecided and I needed his help in helping me make a decision. Well, Dr. McNair was also a very good saxophonist. He went to North Carolina A&T State University in Greensboro, North Carolina, and he told me that I should study engineering. I said, I'm undecided, but if I went into engineering, it would be probably electrical or mechanical. And he said, well, you know what, Tony, you are already good at music. I can tell you are good at it because of your excitement when you talk about it. So don't be afraid to explore the unknown. That's what he told me. And then he said, I was also good in music and I chose to go into physics is what he studied because he was very excited about airplanes. And as a result, he went on to go to North Carolina A&T, and then he went to MIT and got a doctorate in physics. And he said, look, I'm getting ready to go into outer space. This is the unknown. And he wasn't afraid of it at all. He was very courageous about it. Well, unfortunately, on January the 28th, 1986, when the shuttle launched, after a number of delays, my high school was fortunate at the time because he had been a speaker at our high school. And unfortunately, the launch took off. 2 minutes into it, the space shuttle exploded. What happened was one of the solid rocket boosters, it was on the right, failed at liftoff. And it failed because there was an O-ring seal at the joint that could not handle freezing temperature. They were unsure of how it would handle. We'll talk a little bit later on the tool that's used for that. But unfortunately, when that O-ring failed, it caused the rocket booster to fail, which caused the explosion. Now, I do have just a picture of it. There is a video if you want to go to YouTube, and I would suggest parental guidance for all of the videos that we show. But you can actually do a search on YouTube for Challenger shuttle, and you'll see clips of it. But again, parental guidance for that. Also, there is a story corp clip on Dr. McNair, and we'll take a moment and let you watch that, and you'll learn a little bit more about his story. One thing I want you to notice as you compare Mr. Wendell Scott's story to Dr. Ronald McNair's story is both of them were met with some challenges. In spite of those challenges, they were still able to pursue their dreams. They were still able to enjoy their journey in science, and they both left legacies for us as a result of that. So right now, we'll pause and let you watch that clip.
When he was 9 years old, Ron, without my parents or myself knowing his whereabouts, decided to take a mile walk from our home down to the library, which was, of course, public library, but not so public for black folks when you're talking about 1959. So as he was walking in there, all these folks were staring at him because they were white folk only, and they were looking at him and said, who's this Negro? So he politely positioned himself in line to check out his books. Well, this old librarian, she says, this library is not for coloreds. He said, well, I would like to check out these books. She says, young man, if you don't leave this library right now, I'm going to call the police. So he just propped himself up on the counter and sat there and said, I'll wait. So she called the police and subsequently called my mother. Police came down, 2 burly guys come in and say, well, where's the disturbance? And she pointed to the little 9-year-old boy sitting up on the counter. He says, man, what's the problem? So my mother, in the meanwhile, she was called. She comes down there praying the whole way there. Lord Jesus, please don't let them put my child in jail. And my mother asked the librarian, what's the problem? Well, he wanted to check out the books. And your son shouldn't be down here. And the police officer said, why don't you just give the kid the books? And my mother said, he'll take good care of them. And reluctantly, the librarian gave Ron the books. And my mother said, what did you say? He said, thank you, ma'am. Later on, as youngsters, a show came on TV called Star Trek. Now, Star Trek showed the future where there were black folk and white folk working together. Right. And I looked at it as science fiction because that wasn't going to happen, really. But Ronald saw it as science possibility. Mm-hmm. He came up during a time when there was Neil Armstrong and all of those guys. So how was a colored boy from South Carolina wearing glasses, never flew a plane, how was he going to become an astronaut? But Ron was the one who didn't accept societal norms as being his norm. I mean, that was for other people. And he got to be aboard his own Starship Enterprise.
All right. Wonderful. And I also, after I got a chance to meet Dr. McNair, I did not get a chance to talk back to him because he died, but I went on to get an internship once I got to college at North Carolina State University, and I was studying mechanical engineering. I got the opportunity to intern with Pratt & Whitney. At the time, they were located in West Palm Beach, Florida. They have since relocated to Connecticut. They made government engines. They had a government engine business in West Palm Beach. I went there for 2 summers, and I got to, first summer I was a problem history file intern. I looked at crashes and tried to get keywords to describe what those crashes were from different flights. And we were building a problem history file. So I was putting the pieces together of the content for those keywords. And I had to read a lot of documents on crashes that had taken place. And a lot of people survived some of those crashes. They were military crashes, so they were able to eject. The next summer, I worked on the actuator for the wing. So the actuator, they were electric. We were doing a feasibility study as to whether or not we wanted to use electrical, mechanical, or electromechanical design for the actuator. And the actuator just allows the flap to move up and down on the plane. And that flap sets about, kind of helps the plane angle and guide easily in the direction that it's going. But these are a couple of clips, snapshots rather. This is what a gas turbine engine looks like, representative of what I worked on. And this is what the fighter engine, this is an F-16. We worked on engines for the F-15, F-16, and a advanced tactical fighter, YF-22. So some valuable lessons that I learned along the way that took me into my professional life. I would say the most valuable lessons for scientists and engineers that I learned was that it's very fun and inspiring and motivating to create and design and research. So I encourage you to do that, and to do that without boundaries. Let your imagination, just kind of run a clean sheet of paper. You can imagine, you can envision things that have not yet been seen. However, make sure that once you have kind of fine-tuned what you're creating or you're designing or you're researching, whatever that might be, once you have come up with your design or your theory, your hypothesis, you must test repeatedly and thoroughly, step by step, piece by piece. When you test, you are trying to see if there are any things that would cause that to not work as planned. So you're still learning when you test. And you need to understand how things fail how they can possibly fail. That makes a good engineer and a good scientist, someone who understands their design or their process or their theory, and they understand how it can fail. And sometimes you need to get other engineers, scientists involved to share their brain power with you. And together, your brains may even identify some things you had not thought of. And there's a process for that. It's called Design FEMA, FMEA, or Process FEMA, PFMEA. And that stands for a failure mode and effects analysis. And as you get older, you move further into your STEM journey. By this time, maybe college, your first year in your job, you'll be using that tool. But it's very useful. That tool was used on the Challenger space shuttle. And the O-ring failure had actually been identified by some engineers. However, there was maybe a disagreement on how severe and how likely they thought the O-ring failure would be. So you have to be very, very clear with yourself and your conscience and your integrity when you go through that tool. And once you identify the failures and the way things could go wrong, you have to think of how you would prevent or mitigate them, meaning that you would reduce the likelihood or the damage that failure would cause, mitigating the failure and doing what we call risk assessment. As an example of something that you might be able to relate to today is the COVID-19 pandemic. There are a lot of areas in our lives that need to be evaluated with a failure modes and effects analysis. Just simply going to the grocery store now, you have to think about how the virus can be transmitted. It can be transmitted through aerosol. It can be transmitted through air droplets, touching surfaces that are contaminated, and then actually touching your mouth, eyes, ears, nose, your face, and allowing the virus to enter your body. So you have to think of your steps and what you're doing and how you could get infected. And to prevent and mitigate that, you can wear masks, you can wear gloves, and you can limit the amount of interaction you have with other people, which is called social distancing. So that's just an easy example of how scientists and engineers need to do risk assessments and failure modes and effects analyses. And that is my STEM life. I work now at John Deere for Enterprise Strategic Quality, the corporate office. I have been there over 22 years. My title is Six Sigma Master Black Belt. My position is Master Process Pro in the Quality Engineering group. And we do statistical process controls, and we use data and use projects in a series of tools and methods to help us minimize failures, to help us solve business problems, and help us to drive business improvement. Other things I get involved in, Cortechs Robotics, which is a first robotics competition team, first robotics, the National Society of Black Engineers, and I just like volunteering and helping out people. So I hope you enjoyed my short story on my STEM life. Thank you.
So here's this week's STEM Friday challenge, Rube Goldberg. You might be wondering, what are Rube Goldberg machines? Let's start off with this. Who was Rube Goldberg? He was an American cartoonist and inventor. He also did lots of other things like painting, sculpting, and engineering. He's famous for his cartoon machines, which perform simple tasks in very complicated ways. Rube Goldberg machines can do all sorts of simple things. Some other examples of things that these machines can do are flushing a toilet, giving someone a napkin, serving lemonade, pushing a button, or setting off an alarm. Let's take a look at this awesome Rube Goldberg machine. So, what's your task? Your challenge is to make a creative Rube Goldberg machine that puts a ball into a cup. Try and make your machine run for at least. Please submit a video of your contraption working to stemfridays@gmail.com. So let's talk about brainstorming. Here are some ways that you can start thinking about how your machine might be constructed. Remember, you don't have to follow any of these guidelines. They're just some ideas that we came up with. You can do whatever you want as long as your machine accomplishes its task. You can knock down books or dominoes, roll or swing balls, have devices that trigger levers, or any combinations of the previous three. You can roll a ball into a cup, pull over an item with a string, use that string to start rolling a ball, or use simple machines to help you. So those are things like pulleys, levers, inclined planes, wedges, and a wheel and axle. Just make sure to be creative. All that matters is that your machine accomplishes its final goal. When you're building your machine, you have to think about what you're going to build it out of. Here's some materials that you might want to use: a small ball, a regular sized cup, paper clips, sheets of paper, string, books, or any other materials that you might want to use. Just remember to get creative. Please email any questions that you have and your submissions to this email to be featured next week. So that's stemfridays@gmail.com.
Thank you. See you next week.